So, um, dear faculty members of Kaunas Technical University, dear students, my name is Maris Shinka, and as Andreas already told, I am a leading researcher at the Institute of Materials and Structures in Riga Technical University, and also a head of 3D printing, 3D concrete printing scientific laboratory that we newly established only this year. And the topic of my presentation will be 3D printing and construction in a general sense, and also the current scientific and industrial situation in Latvia. So the outline of my presentation and the length, we will try to cover the 3D printing in general, testing and challenges that are faced with that face most of the 3D printing scientific and industrial participants. Also, we will look at documented structural applications that other scientists have documented and reviewed. Topicality in the industry, to see how it's being used by other like different methods, different structures that are being built all around the world. And lastly, 3D printing laboratory in Riga, Riga Technical University, will cover our scientific directions as well as industrial uses in Latvia. The first half of my presentation will consist of the slides from the last year's conference of Digital Concrete 2020. This is a conference that's being held every 2 years, and I highly recommend everybody who is interested in this subject to attend next year's conference. So as I'm using these slides, not all of the pictures and slides will have all the references to the authors or to the places where they have been taken. So if somebody has some interest in what can be seen, please email me. I will definitely guide you to the correct author of the resource. And as I said, yes, next year there will be a third conference on digital fabrication with concrete. This is, I would say, this is the largest conference of concrete 3D printing. It will happen in UK, but probably also virtually. And I checked today that actually you can still submit your abstract till the 1st of November. They have extended. So I would highly suggest everybody interested in this field at least to participate by looking what can be seen, what has been done in this field in the last 2 years. So starting from a little bit in general about 3D printing, here are the different types of 3D printing that's been being done mostly in universities, but in some construction companies also. And you can all debate that whether or not this is all 3D printing. Yeah, because, for example, TU Braunschweig, they are using shotcrete to there is a structural steel and shotcrete to robotic arms are this is produced by shotcrete cement. This is one of the ways that could be a 3D printed wall, or you have these double curved panels where you are printing on a curved surface already. So this is also some a kind of 3D printing. Or TU Eindhoven, who is printing some, you will see later on, bridge parts that are being reinforced. Or D-Shape is one of the first 3D printing companies, but they did this in particle bed. So there is a bed of powder particles that is and a binder is being laser jetted into them. So you can debate that this is all 3D printing, but there are definitely very different technologies, and we will not be covering all of them. What in our presentation and what we deal mostly in a Riga Technical University, we are talking about extrusion-based 3D printing. So it's in this sense we define 3D printing of concrete in which from which a real freeform object is created from a digital file using a specially designed concrete composition or other building material, and with the extrusion-based printer head. So we extrude the material layer by layer. The significance, of course, is a freedom of form that we can achieve with these methods. So we don't need molds. We don't need this waste material of molds. We, of course, increase the automation of this industry, thus largely reducing the amount of low-skilled labor force needed. That will be crucial for the future. We can also optimize structures. You will see later on how we can optimize the structures and how they look if we 3D print them. And hopefully we can get a CO2 reduction from this optimization and from this less waste. But actually nowadays, most of these structures that, for example, you can see here is printed with high amounts of cement. So CO2 reductions still is a challenge for this industry. And also there are different methods that you can do this extrusion-based 3D printing. You can do it as a Danish Technological Institute with fast setting binders, and you can do these free forms. As for example, TU Eindhoven, you are printing and producing reinforcement at the same time, and you build these bridge parts that are connected and use post tension. Or as TU Dresden has envisioned that you can use more traditional concrete and do these traditional type of building material, building structures. So these are all possibilities for extrusion-based 3D printing. And what are the most important steps of this? The four important steps of this extrusion-based 3D printing are, first of all, transportation or pumpability. That is very topical for these materials. The second part is what is happening in the printhead, so extrudability through the printhead. Third is how the material is behaving when it is being extruded, so it's called buildability. So how high can you build when it will collapse? And fourth of all is the behavior of material after printing. So what are the properties of material after it's being printed and what after it had set? We will be looking at mostly of the last three of these steps. So different extrusion modes. We can also look at that extrusion can be with stiff material. We can do it with flowable material, but usually it's done with this oriented pressing. We have this materials that's in between stiff and flowing, and creating this oriented pressing. Here we have a small video from TU Dresden that you see stiff material being printed, but this is not a case for industry. This is only a case for scientific laboratory, as this material is really hard of pumping. So yeah, it's more of a research. And here is really flowable material that really sets really fast. This is from Sika, but other companies are also doing this kind of work on flowable materials. So how can we test this extrudability? There are different methods that we use. Most of them are, some of them are used in the building materials testing nowadays also, but special for 3D printing is we can test the material that is being extruded by measuring energy per unit of volume. So we know how much energy we need and how much material we can extrude. And that's why we can define our material. Is it extruding good or not so well? We can do the viscosity measurements. We can test extrusion force with RAM, or we can do a mini cone slump. This is usually done in the industry, and it's quite easy test to do. Or some similar slump methods as with Soutard cone. And how we can test buildability. Also different different methods, but rheological measurements with rheometers, compression of fresh mixtures, or penetration tests. They all give us the yield stress of the mixture when it's slowly setting. So with these three measurements, we can all get the same property. Why we are doing these tests? Because we don't want to do full-scale printing tests. We can, of course, test every material as it's being printed, but the amount of material that you need to build, test buildability here is much greater than for a small cube. So here is a short examples that if you test this for the same material with rheometer, with uniaxial compression or penetration, you actually get the same results because it's a yield stress of your material. So you can use different methods. What is available for you and what is more easily to do for these materials, of course, and get the same results for them. And of course, post-printing testing. So how can you test these materials after they have been printed? So you can test these materials by taking it into account the direction they have been printed. So you can parallel to the printing direction, or perpendicular, or even sideways, and also for compressive test, because these materials are not isotropic, because they do behave in different directions in different ways. So you need to test these things. We can, of course, test individual elements, but before you test it, you should probably predict how your individual element will behave. So that's why you need material testing. You go to individual elements, and then you go to full-scale tests. And we will later on see why you need a full-scale test for such structures. And one, and last but not least, you also need durability tests, because okay, you can use your material. It might be strong enough, but you also need to be sure that it will last for at least the amount of time that you have predicted to last. So durability is really important for these materials as cement-based also. These materials, 3D printing is also a little bit incompatible with traditional steel reinforcement. Here on the left, you can see this. It was probably still is the highest 3D printed building in the world in Dubai. You can see that the method that the reinforcement is being put in, it's like you just print the contour of the walls, and then you put the reinforcement, and then you fill with traditional concrete. This was the only way how the municipality of Dubai allowed this structure to be tested and calculated. Yeah, because not all of the properties of 3D printed concrete is known, and reinforcement is still yet harder to be put in. There are some other methods, as Shang Teng has shown, but this is not as I did it in 2016. I have been doing since. This is, but none of the companies are reproducing this, and this is not probably the way as reinforcement and 3D printing will continue to evolve. There are different methods. You can do external reinforcement, but as you understand, this is quite prone to corrosion, and this is hard and expensive method. Other is post-tensioning that is being used in industry. So you print these separate elements, and then you join them with post-tension wire. You can add reinforcement in a time of printing. So inlaying the cable. Of course, this is not as a great reinforcement as traditional steel, but it gives these basic properties that you need for these materials to be, because, for example, in this post-tension, here is used also this reinforcement small wire. You can, of course, add short fibers to the mix, but that changes rheology of your materials a lot. And then, of course, these permanent molds, and or as called in 3D printing, so contour crafting, is another way to go, and a lot of materials, a lot of structures are using this contour crafting method as their load-bearing structure. What are the main challenges? These are connected to the printing of the material. These you can evaluate visually. So either you can see that you have been extruding too slowly. You have some buckling if you are extruding too fast, or some tearing when the material is starting to set. This is actually a mild tearing. You can see a quite heavier tearing if the material is starting to set when you are printing. And of course, if you have some small problem in one of the layers, this problem will become a lot bigger in a later on layer. So everything needs to be very precise. One small mistake leads to a huge mistake, a huge problem later on. Different types of failure. Yeah, material failure when material is yielding, or loss of the stability when your structure is not stable enough, it's buckling. So the either you are not extruding your material, or the lower layers are yielding and your construction is collapsing, or it's buckling. So it's different failure mechanisms that we need to test and to see, and this is something that is different from traditional building material testing. We will now a little bit look at the structural digitally fabricated projects in the world. As you can see, actually not that many projects around the world existed. This was for the 2020 conference, but only few, I think, have been added to this list. First, I think, was a quite interesting application, which is only partially 3D printed. So the idea of this structure was that here we have a timber roof. It's not fully roof, and they wanted a 3D printed column. But of course, according to the building code, it was not possible to fully print this column and also in the same time add reinforcement. So what they come up in this this is done by ETH Zurich, and they did it in a way that they printed outer shell of the structure. They wanted to print and at the same time fill with a quick setting concrete. So they have this really nice geometry structure. You have your outer frame that is 3D printed from plastic. You fill it in layers with quick setting material, and you have your reinforcement that is that was built in place. So in this way, this is partially 3D printed structure. You can get interesting geometry, and you can also, in the same time, get that the designer of and who is calculating the loads, he is able to calculate this and allow this to being built. Other application was being built by TU Eindhoven. So this was, I believe, one of the first bridges being built. So the method was that they printed all these separate pieces, and then they are held together by post-tensioned wire. What they did, they actually needed, as this was using 3D printing in the process, they needed to do 2:1 scale model mock-up part of this bridge, and they needed to test it. And this test was for 4-point bending test destructive. So you understand, to build such kind of a structure, you need to make it a 2 times smaller structure and to break it. So this highly signifies the need for research in this area, for it to become more standardized. So this design by testing isn't needed anymore, because this costs a lot of money and it takes a lot of time. There is a way how you can build today, but probably is not the way how can say that this will be cost saving and time saving, because yeah, this is definitely none of those. But this is one of the ways how you can use 3D printing in these with these large overhangs. So you need to use post tension, and post tension is something being done in a traditional concrete industry. This is a pavilion that was being built in Innsbruck. This was, I believe, together with the company Baumit. The way that they designed this structure, okay, it's not so dangerous, probably. It's not a bridge, but anyway, it can collapse on somebody. So it was designed as self-supporting, and the material safety factor was taken as a 2. So you usually take it a lot less. In this case, as there is limited experimental data, So just add a little bit, not a little bit, a lot more material, a lot more safety, so there won't be any problems with this structure. So that is also one way how to design it, and I believe that this was the principle of it was, yes, as a masonry structure it was being calculated. So that's one of the ways how you can calculate such structures. Or here we have a bridge that was optimized. This is from University of Ghent. So this is a bridge that has its geometry optimized, so the material is only in the places where it is needed. So this is one of the ways how 3D printing could allow for material saving. But of course, this also possesses some challenges. As you understand, to print these separate pieces, it was held together by also this post tension wire. Here goes in the middle, and internal cavity is grouted, so it's full, and so it's a solid shape. So in this case, that was a way this was calculated. So another way, yeah, we can. That's the way how we can optimize such a structures. Yeah, here we go to the next segment, that is topicality in the industry. Here we have also a graph showing the number of 3D printing projects being built in the world. Probably not all of them, but you can see the idea of this graph is to show the exponential curve that is amount of the projects, and probably this was the latest year is 2018. Definitely more projects in the last 2 years. But still, if you count the amount of construction being done in the world today, this is so small number compared to the whole world. So definitely enough space for other companies, for other researchers, and still for development. If we here are the few major companies working into this 3D printing industry in the so these two are from Europe, so it's Six3 and Cyber, and Cobot from Denmark. That's Cobot is the one that's building these large 3D printers you have seen, probably together with Perry, building one of the largest structures in Europe. Apiscore, that is now located in USA, as well as Icon, who is building for the US military quite a lot, and there are still a lot more companies working in this field in the world, and we will look at some of them, some of their projects, and we will now I would say one of the distinctions how these companies work is the type of material of 3D printed concrete that they use. This is one from Weber Beamix. So this their choice, like a normal setting Portland cement based mixture, which just has a strong thixotropic behavior. So it means that it holds its own weight and a weight of next layers, but it doesn't set. It's not setting rapidly. So it's still very fresh when you end the printing. But the advantage is definitely you know how these materials work. They are very similar to traditional cement-based materials. And they are definitely a lot easier to be working with. The other choice is this is a one company, 20 Additive Manufacturing. In this video, they are using machinery from Baumit. I will actually a little bit make this go faster. This is a video from their so they live streamed this video from their factory to the one of the conferences that was happening in somewhere, yeah, I think in Dubai. So you can see live prints that they are doing. They showcase how they are successful and also their failures. And you can see this is a very quick setting material. I think soon you will see like what kind of overhangs can it do. So and the way that you achieve this kind of material, you put a set accelerator into the printhead at the very last moment. So it accelerates the setting rapidly. So this material is setting while it's being printed. So this part is already set. So this was the highest continuous print at that time in one go, so 3 meters. And this is the overhang that you can do with that kind of material. This is definitely not possible with traditional, like thixotropic based OPC materials. It's a question whether or not you need these kind of behavior, because you get a lot of problems working with these materials. Definitely a lot more expensive, but of course advantages. You can get a lot greater freedom of form, and this your structure detail of your structure. When you print with traditional, you get more robust but more predictable structures. So usually when I do these kinds of presentations, I look also at the industry activities in a let's say some last 6 months. Of course, I cannot cover everything that is being done in the world, but I think the most interesting projects we can see here. So one of the projects that I already showed was this one of the bridges. So this is the right now the longest 3D printed bridge that was also done by TU Eindhoven. So the materials producer, the materials that they use is Weber Beamix. So these bridges were built in the same manner as I told before. So these are different parts being built in this direction. Then they are connected together with this post tension and installed on site. So this is one of the ways how you can use 3D printing, get interesting structures, but also get certified by doing this. Also, but of course, this meant doing design by testing. This was another very interesting approach was done this year by collaboration from architect Zaha Hadid Studio with ETH Zurich. So ETH Zurich is also using this quick setting approach. So they call it set on demand. So their material is setting quite very fast, and they can print really interesting geometry. So they built this arched pedestrian bridge in Venice this year. What is interesting in this project is that these all separate parts were 3D printed. Then they were put on this wooden frame together, and then the frame was removed. And so it is working as only as a clamped arch. So there is no mortar, no metal joining them. So this is one of the oldest ways how we built arches. So it's like a 11th, 12th century church. The same structure. There they went with stones. Here it's 3D printed. You can say stones. So this is a really interesting way, because with 3D printing, we can do this. Each individual element, of course, is separate. With traditional building methods, this would be quite not a reasonable task to build a mold for each of these elements. But with 3D printing, this is really possible. So this is one of interesting ways how to use 3D printing. You can also use it more traditionally, as Perry is doing. So Perry, they have these large 3D printers that is being produced by Cobot. I think the Perry owns some part of the Cobot, so they have these printers, and they are building these structures right on site. This was the tallest existing buildings in Europe. They use this only layered extrusion, manually inserting only some reinforcement where it was needed, but this was also done according to codes. I haven't yet read the whole explanation process, but as I understood from different lecturers, that this was being calculated as also as a masonry structure, so unreinforced masonry structure, and that was the ways how they was able to certify such a 3D printed structure. So again, you can see that there are different ways how you can certify, how can you use 3D printing in Paris, and they are thinking about the automation here more. So how you can work faster. Okay, you can build some free forms, but this is not radical form. It's quite a traditional looking building. But you can go also in a different direction. This is also very relatable to my research that I'm doing. So this is a project that was done by WASP. WASP is a company that is producing various 3D printers. They are mostly smaller 3D printers, but they have their crane WASP. So there are like more printers attached to this one construction. They built this self-supporting structure, and this is not built from cement. This is built from clay. So you have a clay that is being printed also similarly as a contour crafting method. So clay is an outer and inner contour of this building, and it's filled with a rice husk for thermal insulation. So it's a really environmentally friendly building. The material costs are low, but of course you are limited to the things that you can build. You are limited to the durability of the material. But this is definitely one of the directions that will be interesting in the future, and one of the ways how 3D printing can help to advance these kinds of materials. Of course, you can do also even smaller. This is one company also from Netherlands called Brüel. Their idea here is the building. It's not 3D printed. This is an existing quite rectangular building, and they need to renovate this building. So their idea is to just put these 3D printed elements on top of this older building to make it look 3D printed, well, which is not fully, but this is really helping with the testing, because you need to test only some of these elements, and you can put the others in the place, so you don't need to test the whole building. And so this is also one of the approaches that could be taken. And lastly, I think, yes, so this is also one of the future projects by one of the companies already mentioned, called X3, that is located in France. So they have this, they just made this contract with the municipality of Paris for the 2024 Olympic Games. So this will be probably the largest, longer spanning 3D printed bridge in the world. And I think this is an interesting project to be looking to be waiting in the future. So yes, here we end the part with the topicality in the industry, and let's start with what we are doing in the Riga and why we are doing it. So first of all, we come from a research sector. So this subject of 3D printing, this is also interesting for us from research perspective. Here, there is, you can see two important scientific journals for the construction materials industry, and to showcase the significance of 3D printing. So for cement and concrete research, it was for 2018. Yes, 4 of the 10 most cited articles were on 3D printing. For construction building materials, it was 3 of the 10 most cited articles. And you can also see the number of scientific articles. I think this will go exponentially, Nagiomir. Yeah, so this is also very interesting for a lot of scientists in Europe, in world, and so we are also trying to advance in this field. The how the different laboratories in Europe looks. Here is ETH Zurich. I would say this is most advanced laboratory what I have seen. The amount of equipment and the cost of this laboratory, I have seen some 16 million for this one. I'm not sure if it accounts for the building or no, but anyway, it's quite expensive. TU Eindhoven, they don't have that large laboratory, but theirs was supported by Weber. I think supported their laboratory, but you can still do a lot of interesting things. You have seen these bridges that they are doing, and a little bit a smaller laboratory in Ghent University. You saw also you can do these interesting structures. They don't have such large laboratory as other two, but still with a lot with an experience in other fields, you can get quite far. So it's maybe not all the time only the amount of financial resources that you have, but also enthusiasm and knowledge in other fields that can help you. This is how it looked like in Riga 12 months ago. So we had this incomplete 3D frame printer. It was with a simple printhead, so it's a PVC pipe. It's the motor is from like electric screwdriver. So it was really not that great situation 12 months ago. There was one researcher, me, working on this in this direction, and there was no support from the industry. Now, okay, I want to check if the video is a little bit lagging for you, I guess.
Yes, but it's still quite okay.
It is okay. Well, I could restart. I know, but okay. Now I think it looks okay. So yeah, we established our laboratory in 1st of April this year. This was in cooperation with Sacred. This is a dry mix building material producer in Latvia and also in other Baltic states, one of the largest. So they supported us financially by giving some finances to start industrial doctoral students to study. So we were able to advance our this printer. We completed our printer. We built the first printhead with the variable nozzles. With different designs to test how this is influencing the material, and now also this was done with help from financial help from Riga Technical University, and we are now in the second stage where we advance and connect this to a large mixer and pump to do continuous printing with this. And now we have several researchers and several research directions in Riga working on 3D printing. So what are the main? So as I told to you, so the first one is an industrial PhD student in cooperation with Sacred. So the aim of his study is to study interaction of the printer and the variable parameters and the mixture. So what are the variable parameters? So the nozzle dimension, shapes of the printing, extrusion speed, object shape, layer height. He's been working with several mixtures, mostly with the ones that are being developed by Sacred. And so looking at the interaction of the printer and the mixtures. So we have recently also started a little bit the same. It's a cement-based direction, but we are exploring our own mixtures developed at laboratory, because one of the aims of our laboratory is also to reduce CO2 amount that is in these mixtures. So and ways to reduce the amount of cement. And in the same time, we are testing these materials. We want to test the durability of these materials. So here you can see we are printing these large straight lines. Out of these lines, we cut these cubes or prisms to test compressive strength, to test flexural strength, to test how the joints are holding together. And we will be testing frost resistance and sulfate resistance of these materials to understand how they will survive in the Latvian or Nordic climatic conditions. And yeah, definitely we'll be presenting our first results in the next year's conference. And one of the, as mentioned also here, one of the directions is reduction of environmental impact because right now the amount of cement is still very high for these materials. Here I just put in the photos of how you test in a fresh material. So similarly, so cone, mini cone slump. You can test the setting time. You can test. You print some these larger objects, and then you cut the concrete and test the compressive or flexural strength of these materials. These are all simple tests that can be done in any buildings material laboratory. Definitely the same as that can be done in Kaunas. One other research direction that we have is 3D printing bio-based materials for application in construction industry. So this is my postdoc scientific project. So the aim here is we are printing with the aim actually is to reduce the negative environmental impact of the construction industry by printing materials with biological origin. So in this case, you can see the printing is being done with hempcrete. This is mineral binder of so it's a biological filler is a hemp chive, so it's a byproduct of hemp fiber production. And the mineral binder in this case, it is lime, only hydrated lime, so really something that sets in days, not hours. So you can see that this material actually prints very well. This is at a density of 1,000 kilograms per cubic meter, so quite dense. But you use it as we have discussed with a few of colleagues from Kaunas. So this is contour crafting. You print the outer structure and you fill the inside with the insulation material, probably also bio-based insulation material. So yeah, you can see there is good buildability. Here we have no stabilizers, so nothing, no additives, only binder and filler. But yeah, as I said, only around we cannot go lower than 1,000 with these materials. We have tested with different binders. In this case, we don't use cement-based. We are using materials that be more compatible with the bio-based filler. So we use magnesium-based binder. So it's magnesium oxychloride cement and magnesium phosphate cement. And one of the ways how we did a preliminary testing, we wanted to understand how the compressive strength that we can achieve with these materials and what kind of environmental impact these materials can give. And from these results, we saw that actually the gypsum-based binder is highly interesting, because the environmental impact of the gypsum binder is quite low. Okay, the strength is definitely not that high as for other binders, but this was an interesting direction, an interesting finding on our own. If you want more information, we have an article on these It's called Fast Setting Binders for application in 3D printing of bio-based building materials. It's open access, so you can see most of the results there. One other direction that we took only lately was from my colleague at Riga, Girts Būmanis. So it's a printing use of expanded polystyrene and gypsum to do a 3D printing. So what does it consist of? So it's EPS. This is waste EPS. So it's ground, and these small balls are used. Usually, they are used as a sub construction for floors for sound insulation, and these are used together with gypsum. Here is a process how gypsum is created from secondary gypsum, so waste gypsum. So they crush it, sieve it, and then grind it in a disintegrator to get this and burn it later on. And then you can get the secondary gypsum binder. But in this research, it was commercial gypsum that was being used. So how do you start this? So you need to know the time that your binder will set. With traditional gypsum, the time is quite fast, so we didn't want to do it in the printing in 10-15 minutes. It means that you cannot experiment around that much. So this was with added retarders to the mixture. So you first you start with your binder. You look what's the cone slump of your binder, because we knew for our printer, if you get this cone slump of around 180 millimeters, it would be a good material to be printed. Well, at least it is possible to print that kind of material. So these videos also will lag a little bit, but yeah. So these were also the first few tries to print with gypsum with the EPS. We didn't actually expect it to be printable at the start, but it actually behaved very well. Also, the filler also gives the effect. It's quite light, so the material the buildability is quite good. You can see in the right that actually the lower layers are not that affected. Girts has also measured how does it affect, how does it compact the lower layers. But from what, and we will later on probably publish these results. But what can be seen today, the buildability is quite good for these materials. Yeah, so how does shape change? Because you would use this oriented pressing. So the last layer is not compressed because you don't have any upper layers, but the lower layers are still compressing because of the force that you are applying here on the top. Regarding student involvement in our laboratory, so we have this 3D printing competition that is being organized right now, and it's in autumn and spring semesters. It's in cooperation with our design factory in RTU and with the University of Latvia. So the competition is to design an outdoor object that will be put in a campus of University of Latvia. You can also join as a student from Lithuania, definitely, because there will be teams that will be working on these tasks, but they will also not randomly, but assemble the teams that there is at least one student from Latvia in each team. But you can also join as Lithuanian students. I think it's very useful if you want to work in this 3D printing direction. There will be prizes at the end of the contest. Contest end will be at the end of the March. But you can find more information. Everything is in English at the site printconcrete.com. And also on our Facebook page, there will be some updates. I think you need to register till November. I don't remember the correct date, but if you are interested, definitely register, and you will get all the information about the because these all lectures and everything will happen digitally, so online, so you will be able to attend even from Lithuania. A little bit, and let's end with a little bit on the industry. So one of the aims of our laboratory also to activate the industry in Latvia to be a contact point for all the industry. So a few weeks ago, we organized the first seminar of 3D printing, concrete and building materials 3D printing. So the main representatives of the science and industry was there. And these are the smaller companies that are working on. These are on this is Construs, I believe the page was construs.com. So this is like a freeform ceiling panels. Ceiling panels, here is gypsum. And here's wood wool panels on both sides of the panel that is being built with 3D printing. There are other companies who are working on the smaller objects and on the software of large 3D printers, as Construs, as Profab, and of course Sacred as a building materials producer. And then we have this company 3D Tech. It's actually really new. They only started this year, so they have bought this one printer. It's from a Russian company, AMT. They have these large 3D printers, and the principle is very similar to our laboratory printer. So it's a print head, extrusion based. You put the material in. And here actually we tested yesterday. We brought them our material that we use in a laboratory, and I am really glad that there is at least one company in Latvia that is working on these large scale printers, because they have good connections with one of the municipalities. I think we will see new 3D printed objects really soon in Latvia. That was it of my presentation. Before we end, so we will have our scientific conference in Riga in September of next year. There will be definitely a special section on 3D printing.